Alright guys, what's up? I'm here with number 9 on the exam review. We have a question that appears on the easy and normal versions of the exam. In this problem we have Mr. Bongers launching an enormous drill into the side of the mountain. The drill strikes the edge of the stone with a velocity of 647 meters per second. After drilling a total of 18 meters, the drill comes to a complete stop. How long does this take? It should be a very short time. Cool. Okay, so let's go ahead and draw this out. We got a mountain. We got Mr. Bongers. We got a drill. The drill strikes the edge of the stone with a velocity of 647. We drill a total of 18 meters in. Drill comes to a complete stop. So from here to here, over this distance here, we have the drill. Okay, so the time period we're looking at is actually from when the drill strikes the edge of this mountain to when it goes in and stops, right? So our initial point is here, drill hitting the mountain. Our final point is here with it stopping. Now, if we look at this, we could say, okay, cool, we've got an initial velocity. This velocity that the drill hits the mountain with is going to be our initial velocity. So initial velocity is going to be 647 meters per second. And our final velocity, the speed that it moves down here, is going to be 0. And the reason for that is because it comes to a stop. Right? Fully comes to a stop. It starts at a speed, slows down, stops. So because it stops, our final velocity is 0. We also know that it drills a distance of 18 meters. So this distance between here and here is going to be 18 meters. I'm going to call this 0, and I'm going to call xf over here 18. So let's go ahead and write our variables down. Let's grab them from the equation sheet. We get xi, xf, vi, vf, a, and t. Xi we know is 0. Xf, the distance it goes away, is going to be 18 meters. Vi, the initial velocity, is the speed it hits the mountain with, which is 647. Vf, the final velocity, is how quickly the speed it's moving after it slows down. And we want to know how long it takes the time. We are not given an acceleration here, so we're going to use the equation that does not involve acceleration, which is number 3. Kinematic equation number 3 looks like this. It's xf equals xi plus vi plus vf over 2. You might see this written as 1/2 vi plus 1/2 vf, or 1/2 parentheses vi plus vf times time. So now we're going to solve this for t. We can go ahead and plug our stuff in here. Xf is 18 equals xi is 0 plus vi is 647. Vf is 0. Divide that by 2 times t. So now we can go ahead and solve this. 0 plus anything is just that, so we're going to drop this out. 647 plus 0 is 647. Divide that by 2, that's 323.5. So we get 18 equals 323.5 times t. We want to get t by itself. We got to divide both sides by 323.5. Divide both sides by 323.5. That's 18 divided by 323.5, and we get, put this over here, we get t equals 0.056 seconds. That is a very short time. So hopefully you guys didn't find this one too hard. The drill hits the edge of the mountain, starts at this speed, slows down more and more and more, comes to a stop, so its final velocity is going to be 0. And the amount of time that takes we can find by using equation 3. We use equation 3 because we're not given acceleration. Hopefully you guys should find these helpful. I'll see you in the next one.